Alrighty, homework book, put on your thinking cap. We're finishing the chapter 6, page 133, problem 1. Alright, the area of triangle ADC is 2/5 on the area of triangle ABC. The area of triangle ABD is 16 centimeters squared more than the area of triangle ADC. Find the area of triangle ABC. Very simple, very straightforward. So your fractions, right? So this triangle ADC is 2/5 of the 2/5, right? Remember again your fractions, right? So we have 2 units, right? This is our ADC, basically, right? And so the triangle ABD, this triangle is the whole rest thing, right? Is 3 units. So 2 units and 3 units, right? And what is the difference between them? That's the difference between them. 2 and 2. This is the difference, right? Only 1 unit, and they tell us that it is 16 square centimeters more. So 1 unit. The difference between 3 and 2, 1 unit, right? 16 square centimeters, right? So that's it. They ask us what is the area of the triangle ABC. The area of ABC, of triangle ABC, is 5 units, right? 5 units, which is 5 times 16, right? Which is 80 square centimeters. Easy. The figure below is formed by 4 identical square cards overlapping each other. Each square card has a length of 6. Okay, so this is our length. This is what they show us, 6 centimeters. And find the area of the figure, right? And 3. What is 3? This piece is 3, right? And this piece is 3, and all of them are 3. All of them are 3. All right. Okay. How do we? And like all of them are 6. This is 6, 6, 6, right? All right. So the only kind of a problem, right, is to understand how do we break it down. How do we break it down? Well, if there are 4 squares overlapping, right? We can just think about it like this. We can break it like this. We can break it like this, right? We can also imagine, of course, that there is something overlapping on the background, but we are not interested in that, right? The whole figure is comprised of this rectangle, and this thing is overlapping of 2 squares. That is it. Okay. So basically, also these 2, they are halves of the square, right? Halves of the square. So what are you looking at here? You're looking here at 3 squares, right? This is a square, this is a square, and these are 2 halves of the square. So you are looking at 3 squares, right? 3. So area of the figure. Area of figure is 3 times. What is the area of the square, right? One side is 6 by 6. So 3 times 6 by 6. 6 times 6, right? And it is 108 square centimeters. Easy, right? That was A. Now our B. They tell us find the perimeter of the figure. Okay. Alright, well, if you need to find a perimeter, you're looking at 4 halves of the square, right? You're looking at, I'm gonna erase this thing, like this is gonna be 1 half of the square, right? And this one, so this part and this part is a perimeter of a square, right? And this part is also a perimeter of the square, right? So you have 2 times perimeter. perimeter of figure. Right? So you have 2 times what? Perimeter of the square is 6 4 times, right? 6 times 4. 4 sides, each side is 6 centimeters. This is what you do, right? It is 48 centimeters. Easy. Okay, next problem. Rectangle PQRS shown below is formed by 18 right-angled triangles. Okay, so this is 1, 2, 3, 4, 5, 6, 7, right? And then, so 7, 7. This is 14. This part 14. Then 1, 2, 3, 4. Okay, 14 and 4. Total 18 right-angled triangles. All right, we got this part. The perimeter of rectangle PQRS is 138. Okay, the whole thing. The perimeter is 138. Find the area of each right-angled triangle. Oh, rectangle. What? Yeah, definitely right-angled. This is a typo, right? They don't want us to find a rectangle. Triangle, right? They want us to find the area of each triangle, right? This is a typo, so just ignore this thing. All right. So what do we do here? We need to identify each side. Like let's look at this side like this. PQ. So PQ is the same thing as SR, right? SR, right? It is. Okay, PQ is equal SR is equal 7 units, right? Because we break down, we think that the base of one triangle is 1 unit. 1 unit, and it's gonna be 1, 2, 3, 4, 5, 6, 7, right? So 7 units. 7 units. This is 1 unit, right? Or like whatever. This is 1 unit. Okay. PQ is equal to SR is equal to 7 units. We think of this, right? Now we want to know what is, in that case, what is PS and what is QR in that case. Well, they are both equal to each other. PS is equal to QR. Right? How can we understand what is this? Well, if this is 7 units, it means that this one here, right, is half of the 7 units. So 2 halves of 7, right? So 3.5. This is gonna be 3.5 units, and this is gonna be 3.5 units, right? 3.5 units. This is also gonna be a base, so 1 unit, and this is also gonna be, right? This is 1 unit, right? And this is, we just discovered that this is 3.5 units. So PS, the whole PS or the whole QR is 3, 1 and 3.5, 4.5 units. All right. Okay. So what is the perimeter then? What is the perimeter? Perimeter of the figure is all of these units, right? So 2 sides, 7 plus 7, and 2 lengths and 2 breadth, 4.5 and 4.5. All right, and the total amount of units is 23 units. All right, we know the perimeter. Right? They tell us the perimeter of the whole rectangle is 138. So 23 units is 138 centimeters. Right? So 1 unit in that case. 1 unit is 138 divided by 23, which is 6 centimeters. So we just found our 1 unit right over here, right? 1 unit, base of the triangle, base of each triangle. right? Base of triangle. We found the base of triangle, right? So the height of triangle, we know height of triangle. We know that it's 3.5 units. 3.5 units. So 3.5 times 6 is 21 centimeter, right? So we got our base, we got our height. We can calculate the area. Area of triangle is equal to 1/2 times 6 times 21. 63 square centimeters, right? And this is our A, right? They ask us the area of the triangle. We found the area of one triangle. Now we need to find the area of the whole rectangle PQRS. Well, it's simple, right? We have 18 right angle triangles here, 18 right angle triangles, and we just found the area of one. So we just multiply this number, 63 times 18, 1134 square centimeters. All right, that's your answer. Okay, last problem here. Identical tiles are used to cover a path that is 72 meters long and 160 centimeters wide. Okay, so the length of this, like it's going to be a long pathway, 72 meters. But the breadth of it is 160, right? So they ask us how many tiles are needed to cover the entire path. All right. How do we do that? Well, first of all, we look closely to the picture, right? And we can see that in the way it's stacked. So these three, right? These three tiles, they're same as this tile, right? And we can see that the length of it, the length of the tile is 3 times the breadth. 1, 2, 3, right? 1, 2, 3 makes up the length, right? So this is what we do in this figure. The length of one tile, the length of one tile is equal to the breadth of 3 tiles. 1, 2, 3. Okay, so we know from here, right? So it is 1, 2, 3 here, right? That's gonna be this breadth. 1, 2, 3, right? And then one more. So we know 1, 2, 3, 4, right? The breadth of 4 tiles. Breadth of 4 tiles, right? It's like you put each tile this way, right? For example, the breadth of 4 tiles is 160 centimeters, right? So what is the breadth of one tile? Breadth of one tile is 160 divided by 4, which is 40 centimeters. Okay, the length of one tile then. The length of one tile is 3 times that, right? 40 times 3, 120 square centimeters, okay? And the length of one section, what is the length of one section? Okay, and I'm gonna erase this thing. They basically they understand. So this is one section, right? One section, 4 tiles. This is another section, right? 4 tiles. Okay. Again, like this is the section, and this is the section, right? So one section, 4 tiles, is the same length, right? This is the same length. Same length. Okay, so the length of one section of 4 tiles is 120 also, right? Now, number of sections. How do we find number of sections? Well, that's easy, right? Number of sections. We know that the whole length, right? That's gonna be 72 meters, right? Well, 72 meters in centimeters is 7,200 centimeters, right? That's the total length of the path, right? 7,200, and we know the length of one section, right? So in order to understand how many sections, we just divide 7,200 divided by the length of one section, 120. It's gonna be 60, right? So how many tiles do we need? Number of tiles. We need 60 sections, 60 sections like this. Each section has 1, 2, 3, 4 tiles, right? Very easy. So times 4, 240. That's your answer. How many tiles are needed to cover the entire path? 240 tiles are needed to cover the entire path. That's it. I'm gonna show you the answers, and that's the end of the chapter 6. See you later.